Hello guys, today we're gonna plot displacement versus time graphs, right? So there are three cases when it comes to displacement over time. First one is constant position. Well, what do you mean? What do we mean by constant position? Well, constant position means the position is constant forever. With as we move forward, the position is not changing. As we move forward in time, the position is not changing. That is, there is not gonna be any displacement, right? So if you have to draw a graph for constant position, displacement versus time graph for constant position. Okay, let's say this is the origin, right? And let's say this is the time graph, right? This axis is, I'm sorry, this is the time axis. I'm sorry, this is the time axis. This axis is denoting time, and this one is the displacement axis. I usually use the letter S to denote displacement. Some people use X, some people use D. Alright, it just doesn't matter. Right? So I prefer S. Okay, so what do we mean by constant position? Let's say I'm initially at a position that is 5 meters from the origin, right? And after, let's say, 1 minute, my position is still the same, 5 meters. After 1 month, my position is the same. After 1 year, my position is the same. So if my position is gonna be the same forever, that is, I'm not getting displaced. My displacement is zero. That is, my position is constant position. So as we move in time, my position is just gonna be same. So this is gonna be same at every instant of time. So this is gonna be a straight line, and the straight line is going to be parallel to the t-axis, parallel to t-axis. Okay, so also when it comes to graphing, there's one more important thing, that is slope. So for those who don't know what slope is, okay, so slope is nothing but, let's say if we have x by y graph, y by x graph, whatever. Alright, so in these terms, the slope is always equal to y2 minus y1 upon x2 minus x1. That is my change in y divided by my change in x. Alright, so let's say this is my graph, alright, and I draw a straight line from this. This is my final graph, final position, this is my initial position, this is my graph, this is theta. So y2 minus y1 is gonna be this, x2 minus x1 is gonna be this. So with respect to theta, that is opposite side upon hypotenuse. And what is opposite side upon hypotenuse? So it's gonna be equal to tan theta, because tan theta is opposite side upon hypotenuse. That's it. As we assume that this is x2 comma y2 and this is x1 comma y1. That means y2 minus y1 is this axis, x2 minus x1 is this axis, opposite side upon hypotenuse, that is tan theta. Hence slope is going to be equal to tan theta. Slope is equal to tan theta. Alright. Okay, now when it comes to this graph, what is theta over here? That is, what is the angle it's making with this axis? It's zero, right? Our graph is not making any angle with this axis. So the angle is just zero as it's parallel to this axis itself. So it's zero. So tan theta is, that is tan zero. Tan theta is tan zero over here. That is tan zero is zero. That is, our slope is equal to zero. And for those who know calculus, right, slope, we calculate slope by differentiating y coordinates with respect to x. That is, dy by dx is our slope at an instant, of course. Dy by dx is equal to slope. Why is it equal to slope? Because slope is y2 minus y1 upon x2 minus x1. That is delta y over delta t. Delta x is our slope. y2 minus y1 delta x, delta y. x2 minus x1 delta x. So delta y upon delta x is our slope. And for a very short x, let's say if this is the graph, alright, for a very short x, as delta x tends to 0, this is gonna be dy by dx. Alright, if you don't kind of understand this right now, don't worry, we'll cover it in calculus, alright, in a separate video. Alright, the most important thing for now is slope is tan theta. Alright, it also is represented by dy by dx, and it's over here as tan 0 is, as the theta is 0, tan 0 is our slope, that is 0. Alright, and as slope is 0, dy by dx is equal to 0. And what is dy by dx? If let's say this is for this graph, dy by dx is simply ds over dt, right? Because s being the x-axis, t being the y-axis, ds over dt, and our ds over dt is hence 0, because the slope is 0, theta is 0. That is, our velocity is 0. And we actually know that because we have our position is constant. So as the position is constant, there is not going to be any displacement. That is, delta s is going to be equal to 0. That is, delta s over delta t is going to be equal to 0. Hence, velocity is 0. So in essence, when there is constant position, a velocity is 0, and the graph is just a parallel line to our time axis. Alright, so when we go to case 2, right, that is constant velocity. Let's again draw two axes. This is displacement, this is time. Right, so when we say the velocity is constant, that means there is a change in displacement, but that rate of change of displacement is constant. That is, displacement is changing but at a constant rate. That is, the velocity is constant, as velocity is the rate of change of displacement. So let's say if I'm at 5 meters over here, alright, and then I move to 7 meters, and for me to move from 5 meters to 7 meters, it took me around, let's say 3 seconds. Alright, so let's say this is 1 second, this is 2 seconds, this is 3 seconds. Right. So my final position is gonna be this point, as it took me 3 seconds to go from point this to this. My initial position is this, my final position is this. Right. Wow. So in essence, I traveled from this point to this point. Right. So and as we say that the velocity is constant, we mean that at every instant, as we move in time, right, our change in displacement at every instant of time is the same. That is, the rate of change of displacement is constant. This is gonna be a straight line. This is not gonna be a curved line. This is gonna be a straight line. As the displacement increases at the same rate as the time increases. Alright. So it's gonna be constant. Right. It's not gonna be wavy. It's gonna be constant, as there is a constant increase in displacement. Right. We can also talk in terms of slope. Right. So let's say theta. Right. So our slope is tan theta. And as there exists theta is not equal to 0, there exists a certain slope of this line, and this slope is not changing. And as that's a straight line, it's not changing. And this tan theta is dy by dx, as dy by dx is also the slope. and dy by dx is equal to 0, as tan theta is equal to, I'm sorry, dy by dx is constant, as tan theta is constant, as theta is constant. So this 2 divided by 3, alright, and this actually is delta y upon delta x, as y2 minus y1 upon x2 minus x1. But we can see over here delta y upon delta x is gonna be same as dy by dx, because the dy by dx is instantaneous velocity, as we discussed earlier, and delta y by delta x is average velocity, and these two quantities are gonna stay same as the velocity is constant. That means the instantaneous velocity is going to be equal to average velocity, as there is no acceleration. So these two quantities are just the same. Alright. So that's for constant velocity. Our third and final case, that is acceleration. If there is acceleration, let's again draw the two axes. And this time the rate at which the displacement is changing, alright, that rate itself is changing with time. That is, velocity is changing with time. So in this case it's not going to be a straight line, as the rate is not constant, it's not the same, it's changing itself. So let's say first case, for acceleration, let's say in the first case the acceleration is positive. Acceleration, as we all know, is a vector quantity, right? As the displacement is vector quantity, the velocity is a vector quantity, so is the acceleration. So displacement, velocity and acceleration, all of these three terms can be negative as well as positive, depending upon direction. Alright. So let's say the first case, that is positive acceleration, that means there is increase in velocity, that is the acceleration is positive. Acceleration is actually supporting the velocity, so the velocity is actually increasing in the direction of velocity. If the acceleration is zero, if the acceleration is negative, right, that means that velocity is decreasing with time. There's some resistance to the velocity with the velocity that is in the direction opposite to the velocity. That means the acceleration is negative, as it is gonna change, as it is gonna be lesser. Alright, if it's negative, that is Vf minus Vi upon delta t. Vf is lesser than Vi. Final velocity is lesser than initial, that is the velocity is decreasing, it's not increasing. That means acceleration is gonna be negative. Alright, if Vf is less than Vi, acceleration is negative. Okay, so first case, let's say that the acceleration is positive. Alright, so there is acceleration but it's positive, that is the rate at which our displacement changes is changing. So tan theta, that is the rate, that is the slope, tan theta is equal to ds by dt, that is the rate, is changing and that is increasing. Alright, so as tan theta, we say it's increasing, it's going up. That means theta is increasing, theta is going up as well. So the angle that our graph is gonna make with this axis is gonna increase with each point in time. So let's say this is the first point, this is the second point, this is the third point. Alright, each point the theta is gonna be increasing. Right. So let's say first this second is gonna be increasing. So the theta increases. Alright, with respect to time. So our graph is gonna look like this. No, theta increasing. as we can say, theta is increasing. That means the acceleration is positive. Theta is increasing, right? So the graph is going to look like this. For acceleration being positive, that this is positive acceleration. Okay. Now let's say the acceleration is negative acceleration. Alright. Let's again draw the axis. Displacement axis, time axis, origin. Now, if the acceleration is negative, that means the rate of change of displacement is decreasing. It's changing, but it's decreasing. That is, the theta is going down, theta is decreasing, as tan theta is decreasing. That is, the rate is decreasing. Right? And we say that ds by dt is decreasing, tan theta is decreasing, theta is decreasing. That means at every point as we move in time, right, the theta it makes with the time axis is going to decrease. So the graph is going to look like this. Theta decreasing, as you can see. Theta is decreasing. So the theta is going down when the acceleration is negative. So that's the negative acceleration graph. Alright. Okay, and one more thing I just forgot to mention. Alright. And velocity, constant velocity graph. This is the case when the velocity is increasing. If the velocity is decreasing, it's just gonna be the same, but it's gonna go down. Right? It's gonna go down. This is the final position, and this is the initial position, and that's the final position. And this is the case where velocity is not decreasing, velocity is negative. I'm sorry, velocity is not decreasing, the velocity is negative. That is, as we discussed in the first video, if you remember, if we take this direction as positive, the other direction is going to be negative. So we are not traveling in this direction, we are traveling in the opposite direction. So we are traveling not from here to here, we are not traveling upwards, we are traveling downwards. That is, we are not traveling in this direction, we are traveling in the opposite direction. That means the displacement is going to be negative, hence the velocity is going to be negative. Right? So that's it for this video. Okay, I'll see you in the next video. Thank you very much.